Good evening, all. Welcome to Chemflix. Hi, all. So, in the session, we are going to discuss, we already mentioned here, we are going to discuss about the states of matter, and it is especially for class 9th students, but it is not only for class 9th students, you can watch. And this is, I'm taking this notes from one of the PDF I have collected from the net, and I think it is very much interesting the way they presented the notebook. The way they've written all these things. It makes me so much interested to this notes and notebooks. That's why I'm showing this as such. You can see in detail. We can see in detail. So the states of matter. Okay, for the class 9th students, the first chapter is matter around us pure, and for that we are going to discuss the states of matter here. And it is also useful for class 11th students. They are also discussing about the states of matter while in their chemistry classes. Okay, so here states of matter for 9th students, matter exists in three main states, that is, or phases. They are solids, liquids, gas, or vapor, and the arrangement of the molecules and how they behave determine the state of the substance. The arrangement of the molecule and how they behave determine the state of the substance. So what is this molecule is? A molecule is a group of atoms bonded together. A molecule is a group of atoms bonded together. As you can see here, this is an atom and this is a molecule. So a group of atoms that is bonded together to form a molecule. Atom means, what is atom? We already discussed, right? Atom is the small building block or unit of matter. So if a matter is made up of something, that is a small unit is called atom, and so many atoms joined together or a group of atoms bonded together can be called as molecule. And here we are going to discuss about the arrangement, how it is arranged. Okay, how it is arranged, the arrangement of the molecules and how they behave determine the state of the substance. That is determining the state of the substance. So we are going to study about the states. Which are the different states that you are going to study about? Solids, then liquids, and then gases. So that is the three phases that you are going to discuss. Gas means gas or vapor. Okay, so coming back, the you can see the molecule within a substance are attracted to one another. So you can see here the molecule within a substance are attracted to one another. But each of those molecules has energy associated with how much they move about within the substance. So we are going to discuss about the movement of a particular thing. Okay, movement. Okay, molecule has associated how much they move about within the substance. In the substance, how will they move? So as we already discussed, the arrangement of particles in a solid is like this one, and in liquid is like this one. Okay, this one is B, and liquid, this one is liquid, and this one is gas, where you can see very small far apart, right? So but each of these molecule has energy, and these molecules has energy associated with this. What is this? The molecules has energy associated with this, and with how much they move about within the substance. Based on this energy, they will move within that substance. The amount of movement of the molecule and the distance between the molecules within the substance determine its state. That determines the state. What? The amount of movement of the molecule and the distance between the molecule and the amount of movement of the molecule within the substance determines its state. Okay, now matter takes the form of these states. So how this matter takes the form? So matter, we know that anything that occupies space and have a definite volume or something, then it can be called as matter. Solids, liquids, gas, right? Solids, liquids, gas. So matter takes the form molecules. In solids, molecules are tightly packed together and don't move about much within the substance. You can see here, this is the solid. Liquid molecules are some distance apart and can move about and bump into one another within the substance, right? Bump into one another within the substance, that is liquids. And molecules are bumpy into means just colliding each other, right? Colliding each other, bumping into one another within the substance. Gas molecules are far apart and can move about freely within the substance. Freely they can move. I'll show you how gases, this is liquid, this is the way of arrangement of molecules in a liquid, and this is the way of arrangement of molecules in gases. You can see, right? Interatomic space or intermolecular space is very large in gas compared to solids and liquids. So here we go again. So here a solid has a fixed structure, a definite shape. Its shape and volume do not change. Its molecules are packed closely together in a particular pattern and cannot move about freely. They can't move freely. Okay. The amount of molecule and how they move. Okay. These are the things that makes a matter. Okay. That states of matter. Molecules are able to vibrate back and forth in their place. They get vibrating. They can vibrate in their place, but they are not free to move. But they cannot break the rigid structure. Example of solid is ice, wood, and metal. Now we are moving to liquid. A liquid is a substance that flows freely. They can flow freely. For example, water, they can flow freely. Oil, they can flow freely. Blood, they can flow freely through our circulator, right? Our body, right? It does not have a defined shape. It does not have a defined shape, but it does have a fixed volume. 2 liters of milk, 2 liters of water. It has a definite volume. Yeah, fixed volume. The energy movement of its molecule causes them to overcome the attractive forces between them. This allows the liquid to take the shape of the container that holds it. You know, if you are taking some water in a glass, it acquires the shape of the glass, right? If you're taking water in a bucket, then it acquires the shape of bucket, right? So this allows the liquid to take the shape of the container. Why? The energy of movement of its molecule causes them to overcome the attractive forces between them. Attractive forces between them, it can be overcome by the energy, and this allows the liquid to take the shape of the container that holds it. Okay, clear? Although the particles do move freely, they are still relatively close to one another. They are relatively close to one another. For example, water, oil, and blood. Now, one term I'll introduce you, viscosity. Viscosity. What is this viscosity? The speed at which molecules move in a liquid is called viscosity. Compare, makkale, all of you please compare water and honey. Honey, you know honey, right? And water, you know water, right? So compare the movement of water and honey, or the flow of water and honey. Which one will move faster? Of course, water will move faster, right? And which one will move slowly? Honey will move slowly. Why? Because honey is viscous, highly viscous in nature. Viscosity means the speed at which molecules move in a liquid is called viscosity, and viscosity is the resistance to flow. Resistance to flow. So viscosity, honey is more viscous means it is the flowing is very much resist. Okay, so flow resist. This viscosity. Viscosity is very high means resistance to flow is very high. It is sometimes referred to as friction. Okay, in physics you are going to study, or you are already studied, I don't know. Friction between the molecules of the fluid. That is viscosity. That is the term entirely with the liquid. Entirely related with liquid viscosity. Now we're moving to the next matter, that is gas. A gas is composed of a molecule that are spread far apart, does not have a fixed shape or volume. That is the important thing. Does not have fixed shape or molecule, and intermolecular distance is very high. Its volume and shape are dependent on its container. Volume also dependent, shape also dependent on its container. Unlike a liquid, a gas will expand to fill up the entire container in which it is placed. Gas molecules have relatively high kinetic energy. Kinetic energy means what? The energy of movement, energy to move, or energy of movement. It has high kinetic energy, which means that they move quickly. They move quickly and able to overcome the attraction between them and separate. Attraction between them. The attraction between these molecules. They can overcome the attraction between them and separate. If he blew up a balloon, okay, look how he is blowing up a balloon, right? Okay. So here, if you blew up a balloon and then let it go, the gas inside would immediately spill out and disperse into the air, right? Okay, without tying, a balloon can't keep this air inside, right? Right. So examples for a state of matter you can see here: air, steam, and smoke. These are the examples of gases. Okay, arrangement, state. Okay, this is the ultimate. This is the conclusion that we have studied from this area. Arrangement of particles. This is solid. This is how solids look. The particles are arranged like this. Liquids. This is liquids. The intermolecular space is a little bit higher than that of solids. And this is gas. The movement of particle is very much larger or very speedy compared to liquid and solid, and they are free to move. In solids, they are not free to move. They are rigid. They are rigid. Okay, they are rigid. Features: they have fixed shape and volume. Solids have fixed shape and volume. Liquid has fixed volume, shape can be changed and flow. They can flow, shapes can be changed. Here, compared to gas, shape and volume not fixed, depends upon the container, can flow. Okay, depends upon the container. Shape and volume, it is not fixed, but it depends upon the container. And okay, the gas can also flow. Gas can also flow. Okay. Movement of particles. Now, it can vibrate. Movement means it can vibrate in its own position, but a fixed position. It is free moving. While you move to liquid, that's why they can be flow. They can flow. It is because of free moving. Move quickly and far apart. About gas, they are moved quickly because of the kinetic energy is high. They are moving quickly and far apart. Now, compressibility. Have you heard about liquefied petroleum gas, LPG? LPG, Okay, that is gas. That gas is compressed, right? So liquefied gas, when it compressed, you will get liquid. So liquefied petroleum gas, compressibility. So here you can't compress because there is no space in between them. Okay, so it cannot be compressed. But here you can see some little bit space in between them. So it can be compressed a little, it can be compressed. Okay, so this is the main conclusion or the conclusion from this topic, that is solids, liquids, and gases. How the arrangement of particles, what are the features of solids, liquids, and gas, and the movement of particles, compressibility, all these things you will understand from this. So I hope you guys enjoyed, or I hope you guys have got what we have studied or what we discussed. So thank you all. Thank you all. If you're new to this channel, please subscribe. And if you like this video, please give a thumbs up. Thank you all. Bye bye.